Hello. A couple important concepts from geometry today. So important that I made a title slide. So nothing too major, just some stuff about triangles and other shapes. So let's talk triangles. Two angles, and this goes for anything, not just triangles. Two angles whose measures have a sum of 90 degrees are called complementary. And then two angles who have a sum of 180 degrees are called supplementary. And here's a picture. It's very easy to get those two terms confused. And in fact, I'm not going to make you memorize them. Just draw the picture and just understand it visually. You know what a 90-degree angle looks like. It looks like a right angle. And a 180-degree angle is literally just a straight line. So don't stress about remembering the difference between the two. Just when asked, just know how to do a little bit of algebra with it, like so. So this picture is going to disappear. So get that picture down. Or look at figure 5 on page 138. So this isn't a triangle problem, it's just a general angle problem. Two angles are complementary and the larger angle is 26 degrees more than the smaller angle. Find the angle. So we know what degrees are, right? There's 360 of them and there's 90 degrees in a right angle. And now we're saying that these two angles add up to 90 degrees. That's complementary. So this is the first time we've used like a variable for an angle, so let's make one up. That's the thing we know. It's unsaid, but that's what complementary means. And let's call the measure of the smaller angle x. So we'll often just use the degree measure to refer to the angle. So I could have just said let the smaller angle be x, and I probably will in the future. But really, the angle has a name, and this is the measure of it. So the measure is just however many degrees it is. For a 60-degree angle, the measure of that angle is 60. Okay. So what do we know? We know that x plus the other one is 90. And we know another thing we have to is that the other one is 26 degrees bigger. So since we called the smaller one x, we have to call the other one x plus 26. And then, right, we know that x plus 26 is 90. Those are the two angles. Right, and now it's just algebra. So if you're comfortable setting it up, that's the work. Now it's just the same kind of algebra we've been doing this whole section. This is just a simple linear equation. So you just combine like terms. You don't even need the parentheses there. I just like to put them. So it'd be 2x plus 26 is 90. Subtract 26 from both sides. I didn't show it, but 90 minus 26 is 64. Divide both sides by 2 or multiply both sides by 1/2. You can probably divide 64 by 2 in your head. X is 32 degrees. And now again, make sure we're doing what we were asked. We were asked for both angles. So if you stopped here, that would be a goofy way to lose a point. And it's super simple. So the smaller angle is 32 and the bigger one is 26 more than that. 58. And I always want you to include units. And for degrees, it's as simple as drawing that little tiny degree symbol next to it, right? 58 degrees. And we're done. And then just verify that 32 plus 58 is 90. It is. Here's something that I actually do want you to memorize and know because it's important and it never goes away. It's just a fact of triangles. We're not going to prove it or show you why. It just is. So in any triangle, the sum of all three angles is 180 degrees. You cannot draw a triangle that doesn't have that truth to it. Okay? So highlight that. You have to memorize that fact. The sum of all three angles is 180 degrees. Or pi radians, but you don't know about that yet, so don't worry about it. So let's do an example where we have to know that fact. The smallest angle of a triangle is 40 degrees less than the middle angle. And the largest angle is 25 degrees larger than the middle angle. Find the measure of all three angles. A little bit more to this one, right? So what you want to do, a general strategy is you have to declare a variable, x, t, whatever. And it's going to be one of the three angles. You generally want to make your variable the thing that you know the least about. So you know that the middle angle is 40 degrees bigger than the little angle, and the biggest angle is 25 degrees bigger than that one. So you don't really know anything about the smallest angle. So it seems simplest in this case to let x be the smallest angle. You could do it a different way and still be right, but that's going to lead to like the simplest equation, I think. So let's let x be that smallest angle. And then we have that, okay, the middle one is 40 degrees bigger than that. So the middle one's going to be x plus 40. And then the biggest one is going to be that plus 25. So it's going to be x plus 40 plus 25. Like that. So that's our three angles, all in terms of x, right? You don't want to call them x, y, and z because you don't know about y and z. We don't know about three different variables in a problem, right? We don't want that. We want just one variable so we can solve for it. So it's going to be x plus 40 plus x plus 40 plus 25 equals 180. So that's the thing we weren't given in the problem, but that's the thing that you just have to know. It's inherent in triangles. Right? So the parentheses are mine. They don't do anything. They're just to show you that these are our three angles that we're adding up. And that's our equation. From here, right, just pause the video and shred this equation out real quick. This should be child's play for you at this point. So x plus 40 plus x plus 40 plus 25, you're going to combine like terms. So that's going to be 3x, and then you're going to do 40 plus 40 plus 25. Right, so I just did 40 plus 25 is 65. 40 plus 65 is 105. And we have three total summands of x there. So that's going to be a 3x. Subtract 105 from both sides. Multiply both sides by 1/3. I didn't even show that step because at this point, I mean, you're probably just going, okay, 75 divided by 3 is 25. And there you go. So once again, look back and say, were we just asked for that one, or were we asked for all three? We were actually asked for all three. So that's not the hard part. So the next one up is 25 plus 40, which is 65. And the next one up is that plus 25, which is 90. Like that. Okay, so there's your full answer. The angles, the measure of all three angles are 25 degrees, 65 degrees, and 90 degrees. This is actually a right triangle, it turns out. That's one that has a 90-degree angle. So you don't need to put that, just something to note. Okay, so 25 degrees, 65 degrees, 90 degrees. Okay, let's do the one final one, and this one is going to be trickier. And you could have drawn a picture for that last one. You didn't really need to. For this one, you absolutely need to draw a picture. And if and when I put something like this on a test, I'm going to grade you on your picture. I'm going to say, let me see your picture, and right, I want to see it. Okay, so a rectangular plot has been divided into two fields. The smaller field is a square, and the larger field is a rectangle. A square is technically a rectangle that just has equal sides, but the larger one does not have equal sides. The length of the rectangular field is twice the length of the square field. So you see what I mean? It's hard to visualize as is, but the second you draw a picture, you'll immediately know how to solve it. But we need one more piece of information. If it takes 279 meters of fencing to enclose the entire plot and to divide it into two fields, find the entire dimensions of the original plot. So find all the dimensions of this shape, this square plus rectangle style shape. Okay, so you see what I mean? Like, there's no way to do this without drawing a picture, I think. So take a second and try to draw it yourself, or, just follow along with me. All right, so here's our picture. There's a rectangular plot. It's a terrible rectangle, right? Your picture doesn't have to be good. One part of it's a square. Okay? This part's a square, this part's a rectangle. So what do we even know? We know that this thing's a square. So I think the best way to do this would be to call this, the length on the left side there, let's call that x, or whatever. Okay, so what all do we know? We know that that part's a square. So if that's x, then this is also x, right? That's a square, same side. So this is also x. And in fact, this is also x. And this is also x. Okay, so we got a bunch of stuff labeled. The only thing we don't have labeled is the top and the bottom of that rectangle. So what else? We got to go back to the problem. What else do we know? Okay, we know that the length of the rectangular field is twice the length of the square field. Okay, so by length, obviously, we're referring to that top and that bottom because the width is the same. So, well, if this is x, what's this? 2x. Right? And it being a symmetrical rectangle, this is also 2x. All right, so now we have absolutely everything we could possibly need to know about this thing. So the picture's about to disappear, so make sure and get that down before you move on. We're going to add, so let's see, what else do we know? If it takes 279 meters of fencing, there should be an S there, to enclose the entire plot and to divide it into 2 fields. So that's the outside of our big enclosure of our plot, plus that middle fence that separates the 2 of them, right? So that's important. So here's what it's going to be. Starting at the top left corner, it's going to be x plus 2x plus x plus 2x plus x plus x plus another x for the little thingy in the middle is going to be 279. Okay, so here we go. Right, so I started at that corner, went clockwise, and then threw on that extra x at the end. So x plus 2x plus x plus 2x plus x plus x plus x is 279. All right, and then now's the easy and fun part. So just mash all that stuff together. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9 factors of x on that left side. 9x is 279. Divide both sides by 9. X is 31. So what you can do, you don't have to, but you can redraw the picture if you want, now that we actually know what things are. And just to verify that it makes sense. So there's my picture again. That's a better rectangle. We know that's 31, so that means that's 31, and that's 31, and that's 31, and that's 31. And then the top and the bottom length are 2 times that, so 62, right? See how I did that? Just did 31 times 2. And when we say find the dimensions of the original plot, so the plot that was like before it was divided, we actually want the whole top and the whole bottom. So 31 plus 62 is 93. I'll make that more clear in a second. So that's actually 93. So the original plot was 31 by 93. Okay, so the width is 31. The length of the whole thing is x plus 2x, which was 31 plus 62. Like that. 93 meters. And then again, include units. And that's as simple as just looking back at the top and be like, were these feet or meters or kilometers or what? They were meters. So the width is 31 meters and the length is 93 meters. That's the full, complete answer. Okay, so this is not geometry. This is something a little different. Uniform motion. That sounds fancy. It is actually, these are actually a little tricky. So the way I'm going to show you how to do it by making a table, this is absolutely the way that you should do it, at least for right now. So like I said, just follow with me. We'll define some stuff. If an object moves at an average speed r, the distance d covered in time t is given by this formula. So that's a very famous formula. You don't have to memorize it. Distance equals rate times time. So just think about that in terms of your car. If you set your cruise control and you're going at 50 miles an hour and you drive for 2 hours and you never change your speed, well, you just went 100 miles, right? Okay, how did I do that? Rate times time. 50 miles an hour for 2 hours is 100 miles. Okay, so it's as simple as that. And now when we say average speed, that's like a little above this class, but you could easily do that for a trip you took. If you just drove 120 miles and it took 2 hours, obviously your speed was changing and going up and down in that time, but your average speed was just 120 divided by 2, which is 60 miles an hour. Okay, so you'll get reintroduced to this whole concept in Calc 1, but we'll worry about that when we get there. Okay, so the distance d that you cover in time t is given by that. Distance equals rate times time. We use r for speed because it's rate. So we're going to use this formula to make a table that looks like this. Okay, so get this table down. We have 2 different objects. Those objects could be bikes or cars or people or particles or whatever. Object 1 is going at a certain rate. It's going to do that for a certain time. which means when you times those two things together, that's going to give you the distance that object 1 traveled. Object 2 is going to be going at some different rate for some different amount of time, or maybe, and that's going to tell you the distance that object 2 travels. Okay, so if you a lot of times if you set up a table like this, it's very helpful. Okay, so let's just do an example. 2 cyclists leave a city at the same time, one going east and the other going west. Obviously, like due east and due west. The westbound cyclist bikes 4 miles per hour, so you know what mph means, right? Miles per hour, faster than the eastbound cyclist. After 5 hours, they are 200 miles apart. How fast are the cyclists traveling? A lot to process there. We're being asked for their rates. And again, we have to assume the rate is constant. Otherwise, you need calculus. So what do we know? We know that the rates are 4 miles, 4 apart from each other. We know that the time is actually going to be the same. They've both been biking for 5 hours. Sounds exhausting. And then we know that the total distance they are apart. So we don't really know the distance that guy A and guy B traveled, but we know that, okay, so just picture it. I'll draw a picture in a second. They move apart from each other, and at that moment, they're 200 miles apart. So let me draw a picture. It's not going to be that fancy of a picture. So we have to assume they both started from the exact same place. Sorry. So here's where they started. One of them, okay, went west, so that way. And one of them went east, so that way. Let's see, the east guy went a little slower, so that arrow should, I guess, be a little shorter. The total distance they are apart is 200 miles. And then, you know, all you can really do with your picture is just indicate the rate. So the east guy is going, let's say, R. He's going a rate of R that way. And then we have to call the other guy's rate something. And so to do that, we use the other piece of information. We don't want to call it R2. We want to put it in terms of the other variable we declared. So it's 4 miles faster. So this guy or gal is going R plus 4 in the other direction. I'll make all that clear in a second, but that's a fact. And then we can't really put it on the picture, but this whole thing took exactly 5 hours to happen. Okay, so let's write all that down. So here's our table. We got our eastbound bike and our westbound bike. The rates, like we just saw, the slower rate is going to be R and the faster rate is going to be R plus 4. Now, if you called the faster rate R and the slower rate R minus 4, guess what? It would still work. That's a perfectly valid way to do this problem. So this is one of those things where you can do it a little different than your neighbor, Zoom neighbor, and you can both get the right answer. Okay? So first guy went a rate of R in a time of 5 hours. You have to make sure the units all match, but they just do, and I'm not gonna like mess with you like that. So it has to be miles and hours. That way the distance is miles per hour. So R miles per hour for 5 hours means you went 5R, right? 5 times R. That's why we put the little time sign in our table. All right, and then other bike, rate of R plus 4, right? The faster one went R plus 4. So we're going to put that in the rate column, and then it's going to be 5. So it's the same amount of time. And then the distance that bike traveled is the same thing. It's just the product of those two things. R plus 4 times 5. Or 5 times R plus 4. You need the parentheses there, right? Because you're multiplying by a sum. 5 times R plus 4. Okay, so all you really need from that table now to do the math is the distance. So the only other thing we know here is that the distance between the two is 200 miles. So this bike went 5R miles, this bike went 5 times R plus 4 miles. They are a total of 200 miles apart. So that means this distance plus this distance is 200. That's our algebra. Right, and this is why I make show you work, because the setup here is the work. The actual math problem is super easy. Right, so that's what we need. The sum of the distances is 200. And that's our equation. Okay, so just bust that out. Distribute, so 5R plus 20, right? Combine like terms on the left side, you're going to get a 10R, and then in one move you can do that, and you can chop the 20 off the other side too, so you can subtract 20 from both sides, like I've done here. There's nothing wrong with that at this point. We're moving up in the world. Okay, so 10R equals 200 minus 20, which is 180. Just divide both sides by 10. That's very easy to do. R is 18. I don't know if that's realistic for a bike or not. So R is 18 miles an hour. And then again, go back and look at the original problem. It says, how fast are the cyclists, plural, traveling, right? So get the other bikes' speed as well. And that's as easy as just doing 18 plus 4. So, and then you just have to remember, you call R the slower rate. So the faster rate is going to be more than that. So it's 18 plus 4, which is 22 miles per hour. Okay, so that's the total answer. The eastbound bike is going 18 miles an hour, and the westbound bike is going 22 miles an hour. So absolutely try a couple examples of that in the homework. These are not easy. This might be the trickiest thing we've done so far. So the only way to do it is just to do it. So get in there and do it. Okay, thank you.